All right, so we're going to go over lesson 5, which is all about horizontal shifts. Horizontal is to the left and to the right. So we're talking about shifting our x values to the left or to the right. And this is a little counterintuitive if you understand how to shift y values, which is the next one. But if you think about, like, remember for example, this one, y equals some value of a, that a value might be 1 or -1 times x plus, minus h squared plus k, right? And remember, this minus means you take the opposite of what your x value is to make this whole term 0 to figure out what your x-intercept was, right? Or that your vertex is. And so this is the x value of your vertex, and this is the y value of your vertex. And you remember you have to swap the sign for this one. So because this is a negative, if I'm going to shift, if you notice, let's say I have this red one is f sub x. I have these points here. Well, this is a little bit bigger. So like at that point, this point, and this point, and they all shift. They all shift over this one's corresponding point on g sub x, right, is right here. This one's corresponding point is right here, and this one's corresponding point is right here. So let's get rid of that confusing point. So this point shifted from here to there. This point shifted from here to there, and this point shifted from here to there. And each one of these, the difference in x is 4, right? This is the delta x, right? So in this one, the h term here is 0, so it's going to be minus 0, and the k term is 0 as well because this k value just shifts it up and down, and this is the y value of my vertex, right? But what happens if I shift this over 4? Am I adding 4 or subtracting 4? What does this sign tell me to do? Well, I have to do the minus 4, right? And that's what makes it counterintuitive. If I have to make it shift 4 to the right, you have to subtract 4, right? And it's going to be like that for like almost all of your different functions, right? And then for your y value is to shift up and down, but that's the next lesson, right? So let's answer some of the questions below. So describe how this thing shifts. We have to 4 is added to each x value. Okay, so if you see from here, this is g sub x, this is x sub x, right? My y values all change by 4, right? And if I look here, the y values are the same. So for f sub x, when x was -1, y was 1. When x is 0, y was 0. When x is 1, y was 1, right? And my transformation for my points all added to 4 here, right? So it's going to be, for my y value, the same points, same values, right? When x is 3, y is 1. When x is 4, y is 0. When x is 5, y is 1. So that's the relationship right there. So explain the changes in x. So we had to add x. We have to add 4 to each x, which is this right here. This is that's supposed to be a 4. Delta is 4. We had to add 4 to each x, right? But if I want to say that g sub x is going to be, I'm going to have to shift it to the right. So it's actually going to be g times, well, not g, but f, excuse me. It's going to be f sub x minus 4 algebraically. Sorry, my mouse got caught. Minus 4 algebraically. So to write my equation, g sub x equals, it's going to be the quantity, it's 1, right? Because it didn't have anything out in front of it, okay? And it's going to be x minus 4 quantity squared, and that is it. G sub x equals, and that's going to be, if you want to do plus 0, that's fine. But there, I can say it because this gives me my x-intercept at positive 4, because you have to take the opposite of my h value, the opposite of my h value. Okay, so let's complete the statement here. Okay, so completing the statement, the graph of g sub x is a horizontal shift of x sub x, right? So, and how does it shift? We had to add 4 to each x value, and to each x value, yep, for each corresponding y value. So that's what we have here. We added 4 for each x value for the corresponding y values. Okay, on the points in the equation, you have to subtract 4. Okay, so remember that here when we're doing these. So here, this is all I did here from this one, from my f sub x function to my original equation to original function, is all I did was they took the y and they changed it to f sub x, right? So this is going to be f of x equals the absolute value of x. This is going to be f of x equals x cubed. And this will be f of x equals the square root of x. Okay, so what do I have to do to this function here, right? Notice here it's a left 2, so they have to do the opposite. Left is subtracting, right? This to that way, which is less. But because of the way these functions work, you have to do a minus 2. So this is going to be a minus 2, or excuse me, a plus 2. It would be minus if it was intuitive, right? But it's not quite as intuitive. You have to flop the sign. So I'm going to be plus 2, okay, for x values. When you're dealing in x and horizontal shifts, you have to swap the sign of what you want to do, right? It makes me want to say I gotta go plus 4, but I'm actually going to go minus 4. Left, it would make sense to go left 5, but I'm actually going to go plus 5. And then right, it's going to go plus 3, so I actually want to go minus 3, okay, in the equations, okay? So the points, if I were just going to say, hey, what were the points? I just got to add 4 to find the new point. But in the equations, I have to subtract 4. So f of x minus 4 is going to be, well, we're doing absolute values. Whoops. So, that's still right. So f of x minus 4, f of x minus 4 equals the absolute value of x minus 4. Okay, so there's that one. All right, this is going to be, I'm going to do the f of x plus 5. And it's going to be x plus 5 cubed. And then it's going to be the square root of negative 3 of x minus 3, right? So it's going to be f of x minus 3, which is going to be the square root of x minus 3. Okay, so that's how you fill out that one. All right, so here is my original equation, my red one. And then I have another equation, which is my final after my transformation is shown, right? How does f sub x compare to g sub x, right? F sub x is a 3 units to the right of g sub x, right? So if you look at this point here and this point here, they are 3 units apart. And you could say that g sub x is 3 units to the left, or f sub x is 3 units to the right. It is delta x equals 3. Okay, yeah. So you can say that g sub x is 3 units to the left, or of f sub x, or you could say f sub x is 3 units to the right of g sub x, whichever way you would like to say it, right? So how does this? So that's that one. I already kind of explained that. It's up here. Okay, so which one is more appropriate? So g sub x is saying my initial equation is going to shift g sub x. G sub x is going to shift to f sub x. Okay, so how do I need to add 3 to the right. So go from g sub x, right? It's going to be plus 3 to the right. Or actually, I'm actually, sorry about that. It's a little confusing. I'm actually going from here to here, right? Because I'm figuring out what g sub x is, right? So to go, if g sub x is going to be equal to as compared to f sub x, so I'm going to be shifting it this way, right? So I'm going to be shifting it this way, right? So it's going to be to the right, which makes me want to add it, but I actually, hold on a second. All right, so we're going from f sub x. We're trying to say what is g sub x in terms of f sub x, right? So if I want to go from f sub x to g sub x, I have to subtract 3, right? So in my equation, I actually have to add 3. So it could be confusing and counterintuitive at times. So I'm going to have to add 3 to go to the left 3. Okay, so it's opposite of what you may think it is. Okay, so sorry about the little hiccup at the end. Hope this makes some sense there. And we'll move on to lesson 6 next.